through some technical issues. Hopefully the attendees that are online, and I think there's a little more than a dozen of them, can hear me okay. Unfortunately, we're not able to promote you if you're attending online right now as an active participant. You can use the Q&A function though. So we're going to try to work through those issues, but it may be that you're not able to unmute yourself for the entire meeting, but you can use the Q&A function. So we encourage you to use that. We're monitoring the Q&A log, and we will pause the meeting to advance your question to the presenters if possible. But again, I apologize if you're attending online. You're not going to be able to unmute yourself or use the chat feature. You can use the Q&A feature. Okay. The meeting is also being recorded. I want to remind everybody of that. After this, it'll be posted to the Charlotte IBT webpage. Do it there. Let me jump right into the agenda. I'm going to go through, well, I'm going to turn it over to Angela in just a minute for a welcome. We're going to review the purpose of the Stakeholder Advisory Group and what your anticipated role is. Leslie Jones of Brown and Caldwell will give an update on the IBT status, including the NC Collaboratory Study, where that stands. And then we have Sarah Ye, Angie Skangas, and Adam Sharp here today from HDR to talk about hydrologic modeling of both the Catawba Wateree Basin and the Yadkin PD Basin. They're going to dive into the details of the modeling, talk about modeling that was performed as part of the Integrated Water Resources Plan, and basically explain how the models can be used to help us with this IBT process. To wrap it up, after lunch, we'll do an overview of some of the upcoming workshops that are anticipated, and then we'll open it up for some final Q&A. So with that, I'm going to turn it over to Angela for a brief welcome.
Thank you, John. Good morning, everyone. Again, I'm Angela Charles, Director of Charlotte Water, and I thank each and every one of you for being here today. Your role is very important in this process, and it's significant to our region. And your input in this process will ensure that we're being transparent, informed, and reflective of the communities connected to the Catawba River Basin. So since our last workshop, we've continued advancing the technical work, supporting our environmental impact statement for our modification application. Many of you joined the Modeling 101 webinar, and it introduced how hydrologic modeling supports this effort. And today's workshop is going to build on that Modeling 101 workshop that we had. You'll hear from experts today with who worked on the Catawba Wateree Basin model. And this is the model of record and is a key tool that will be used for broader planning and for the IBT evaluations. So this process involves many communities, many jurisdictions, and many water users. And so this makes your participation especially valuable to us. So your questions and feedback help ensure that we're considering a full range of perspectives as we move forward. So thank you again for being here. We're looking forward today to a productive discussion. That's what we want to happen today. And so I'll turn it back over to John. He's going to talk about the purpose of today's workshop and then the role of the Stakeholder Advisory Group.
Thank you, Angela.
Thank you. John, one more thing.
Yeah.
We do have Charlotte Water staff in the back. If you raise your hand quickly, I know you introduced the consultants, so we've got folks back here. And also consultants, if there were any consultants who weren't named, we thank you all for being here. Okay, John, thanks.
Just a few quick housekeeping items. We will have box lunches around noon. If you need to step outside for a call, you can step out that way or into the hall. Restrooms are over here. My right, your left. that covers it. So the room has mics. Anywhere you are, hopefully those mics will pick it up. I ask that if you have a question or comment, begin by just stating your name, especially for the online folks, so they know who's talking. I'll remind you of that throughout the discussion. I think that's it for housekeeping items. Again, just a reminder of rules of the road. Respect the interest and opinions of others. Be ready and willing to contribute. We want to have a lot of good discussion. We want to encourage questions, especially when we're diving into some of the technical portions of the models. Again, if you're online, please use the Q&A function. We want to try to get you engaged as well. And if you're a member of the public and you're listening online and you have questions after today's meeting, you can email those and there'll be instructions at the end of the meeting. So just a reminder of what the role of the stakeholder advisor group is. We're looking for your feedback on proposed approaches as we go through this technical work. Brown and Caldwell is going to be working diligently and has already started working on the environmental impact statement. We're looking for your feedback later this year on draft chapters of the environmental impact statement. We want your feedback on the alternatives to evaluate. We already got that from our first workshop, and we're going to run through those here in just a second. And perhaps most importantly, we want to make sure we're engaging and getting local perspective and concerns so that we consider all issues. We really appreciate your feedback in that regard. It's been almost 15 months since we had our kickoff workshop back in December. There we talked about interests, concerns, and opportunities. I'm going to review those in just a second. And then we've had a series of webinars since then. Talked about Charlotte Water's Conservation Water Use Program. We reviewed river and reservoir management. That was Tammy Steyer of Duke Energy. And then DEQ staff went through IBT processes and regulations. And then just a week or two ago, we had an intro to hydrologic modeling. So that sets us up hopefully for today's discussion. If you think back 15 months ago for the first workshop, we had kind of a brainstorming discussion session about identified concerns moving into this IBT process. And some of those concerns are listed on the slide here. The potential impacts to water quality, sustainability of regional water resources. There's a lot of discussion about the efficiency and making sure that all the users in the basin were efficiently using water. There was a lot of discussion about a basin-wide holistic approach, engaging both North and South Carolina and making sure that North and South Carolina coordinate on regulatory decisions. Some of that then bled into a discussion of how could management of regional water resources be made more effective. A one water strategy was certainly mentioned, and that's been highlighted in the draft integrated water resources plan that is available for public comment right now. Larger dialogue, regional policy collaboration, working across basins, of course. There was discussion about water quality improvements, how that might be an outshoot of this IBT process. There was a comment about using North Carolina's ecological flow standards across the basin, and then, of course, encouraging more efficient industrial water use. At the end of the meeting, we brainstormed on actionable alternatives. Charlotte Water has also, through public meetings, asked the public for alternatives. The actionable alternatives that were identified in that initial workshop are listed on the screen here. A few of these are actually mitigation strategies, but this is the core list of actionable alternatives that we'll revisit during our next workshop. Finalize that list as we get more into the environmental impact statement. Any questions about workshop number 1 before I move on? Okay. With that, I'm going to turn it over to Leslie Jones of Brown and Caldwell, and she's going to give a brief update on IBT status and some of the work that's been going on at the state level.
Thank you. All right, so since it has been 15 months since we have last gathered as a group, just a couple of slides. We are still in the prepare the environmental impact statement phase. This is a multi-year process. This is where we'll spend most of our time. So as John mentioned, we are working through different parts and aspects of the environmental impact statement. new or modified IBT certificates, 15 MGD or larger until March of next year. So the collaboratory study is due back to the legislature at the beginning of the year. We'll be looking for what their recommendations are. And then the moratorium will be lifted right now as of March 1st of next year. I'll turn it back over to John.
Any questions about legislation, the NC collaboratory study? I don't necessarily have answers, but I want to pause and see if anybody has questions about that. Okay. All right. With that, I want to introduce staff from HDR. Sarah Ye, Angie Skangas, and Adam Sharp are going to be handling most of the presentation, and it's going to be a little bit of a team effort, I believe. Sarah's going to initiate that, and we're going to spend the next chunk of time first focusing on the Catawba Water Re, the CHEOPS model, how the model's been used, what the model looks like, building off of that workshop we had, or webinar we had a couple of weeks ago. I encourage you all to stop and ask questions as we go through this information. There's a lot of detail here, but I think it's really good information to understand, especially when we look to get your feedback on how we can best use the models to evaluate the alternatives. With that, I think I'll turn it over to Sarah.
Yes, thank you, John, for that introduction and welcome. And so, as he mentioned, a quick overview of what we're going to be walking through as a team with you all this morning is first starting with the Catawba Watery and that basin modeling effort, introducing first the Catawba Watery Water Management Group, how they're developing the Integrated Water Resources Plan, and as part of that plan, then updating the Catawba CHEOPS model, which is the hydrologic model for the basin. Analogously, we're going to then walk through the Yadkin PD Water Management Group, introduce them, their long-range planning effort, which is the Water Resources Plan for the Yadkin PD Basin, and the corresponding hydrologic model, the Yadkin PD OASIS model. So with that, I'm going to start with the Catawba Watery Water Management Group and their Catawba Basin model. So Catawba Watery Water Management Group, I think this organization may be familiar to several of you, but most importantly, this is a group of 21 member organizations spread throughout the Catawba Watery River Basin, and they have origins in joining together back in that 2003 to 2006 era when Duke Energy, who manages the river basin and system, was going through FERC relicensing and had a supplemental voluntary stakeholder process as part of that. Those folks who got together during that 03-06 stakeholder process, many of them and a few additional got together and were finally incorporated as the Catawba Watery Water Management Group in December of 2007. And they are a nonprofit 501c3 organization. That was a result from the comprehensive relicensing agreement. That's the CRA up on the screen. A benefit of part of that incorporation of the group was the creation of the organization resolved some friction between Duke Energy and those withdrawing member water utilities concerning some water withdrawal fees. And in addition, this group is incorporated and referenced within the 2010 Supreme Court settlement agreement that was ongoing from that time period when the lawsuit occurred between South Carolina and North Carolina within this river basin. And finally, a point about this organization is that this group continues to grow and expand, starting from those origins in 2007. In 2020, they made the decision to update their bylaws to expand the coverage area of the basin organization, so extending down to the confluence of the Watery River with the Congaree River, and additionally allowing some other new membership opportunities for water utilities that may not have necessarily a direct intake to the system. And with that, you're gonna ask what is their goal and missions? So with this organization, their mission statement's up here on the screen. I won't read it out to you directly, but I think it's important to identify that this group is coming together and understand they're coming together to collectively identify, fund, and implement projects that for the entire river basin will serve their community and protect and enhance the ecological health of the basin. And in order to achieve that mission as well, their vision is that going forward, there's going to be a future with sustainable water source. And to get there, you're going to have proactive planning, cutting edge research, and be prepared for water shortages. So those pieces, you're going to see those themes, really proactive planning on that long-term phase, having sound research, and be prepared for water shortage. It's going to tie into this integrated water resources plan that we're going to talk about. So this plan, integrated water resources plan, one key feature of why this plan came to be is that during that US Supreme Court settlement that I mentioned, it outlines a need to develop a comprehensive basin-wide water resources plan and update it no less than every 10 years. So this plan is fulfilling that need. And importantly, this plan is providing that long range, 50+ year outlook to identify collaborative actions to support the system and ensure that water supplies are lasting longer. The map that you're seeing on the right-hand side demonstrates, you see each of those little blue labels are each of the reservoirs along the Catawba Watery system. And then the purple labels correspond to each of those 21 members that are currently engaged with the Catawba Watery Water Management Group. I want to point out that we have folks spread honestly pretty well throughout the entire space, beginning up in the headwaters towards Lake James, Morganton, all the way down to Lugoff, Elgin, and Camden involved, below Lake Watery, and Charlotte Water as well is a member there in that middle portion of the basin. So with this plan, what is it coming out to do? And its goal and purpose is to identify both water quantity and quality issues, have those issues and concerns, and then evaluate potential strategies in order to solve those identified issues. And those strategies are intended to be able to implement practical solutions. And I think this is the key part, that there's solutions that can be coordinated on this basin-wide level. Individual members have opportunity, of course, to conduct long-range plans on their own, but the benefit of this integrated water resources plan is to collectively identify those issues, strategies, and try to coordinate implementation. I do want to point out that this IWRP hits those two words, water quantity and water quality. A lot of the focus of what we're going to be talking about here today is going to be centered on that water quantity side, but this addition of water quality into the integrated water resources plan has been a foundational piece. I'm going to tell you a little bit about the integrated water resources plan evolution here before I hand it over to Angie to talk about our modeling tool. So I referenced with the beginning of the Catawba Watery Water Management Group, coming out of that 03 type era when the comprehensive relicensing agreement was being negotiated, and Duke Energy put forward a comprehensive water supply study in that relicensing effort. So that's in 2006. The basis of that plan was then updated to develop the first water supply master plan in agreement with that settlement agreement in 2014. and was further updated and amended in 2015. Keeping with that no less than every 10-year renewal schedule, in 2021, the Catawba Water Management Group took a look at their plan. They knew they needed to update it and enhance the plan's scope to include things like water quality as an emphasis, and renamed it, going from Water Supply Master Plan to Integrated Water Resources Plan. And that shift is to help encompass that slightly broadened scope. We're happy to say that the update with the Integrated Water Resources Plan, we have a final draft of the Integrated Water Resources Plan that was completed in December of this past year in 2025. And it's components of that final draft that we're going to walk through with you here today. And so with that, I'm going to pass it to Angie Fingus to talk about our Catawba Kiops model that makes a lot of that process possible.
Thank you, Sarah.
And Angie, just have a pause really quick. Aaron, no questions in the chat or anything? Good. Okay. All right. Yep. Go ahead.
All right. So as Sarah mentioned, I'm going to talk about the Cheops model for the Catawba Basin. This model has been applied and in use for about over a decade now. In 2013 and the master plan in 2014, 2015. And then as Sarah mentioned, for this IWRP that we're working on now. So what is Cheops? Cheops originated because we were looking for a tool in order to model the hydroelectric systems. When it started, there wasn't really anything out there. So this was something we developed in-house with HDR. So Cheops, what does it stand for? It's a little dated, but so Cheops stands for Computer Hydroelectric Operations and Planning Software. It does fulfill the North Carolina basin-wide hydrologic model requirements for this basin. And using these tools, it really allows us to look at alternative scenarios. So we can use it for such studies as the IBT and the Integrated Water Resource Plan, and looking at potential future conditions and allowing us to really model those alternatives. So what does this look like? What does the basin look like in the model? We are modeling the Duke dams and then the 11 associated reservoirs. So those cascading reservoirs throughout the Catawba Wateree. I'll get into it in a lot more detail, but the model is incorporating all of the operational requirements as well as the hydrologic inputs to the model. So what's going into the model now? We're actually networking with the RTI waterfall model for the hydrologic inputs to the Cheops model. So waterfall is a process model or a rainfall runoff component as well that allows us to simulate rainfall temperature and then run that rainfall through land use and soil types in order to create an inflow time series that we're then inputting into the Cheops model to simulate those reservoir operations, truly the infrastructure, and then also the water withdrawals and discharges. We'll get into a lot more detail on what goes in and the outputs of the model. But through that ops model, we're able to simulate reservoir elevations so that we can see impacts on elevations, releases, downstream releases, both main stem and outflow power generation as well. And another piece of the waterfall component is waterfall allows us to look at water quality, as Sarah mentioned. So we're not going to get into that specifically today, but that tool allows us to look at that component when we're looking at alternatives as well. So what does Cheops look like? I know these are kind of hard to see at this scale. So on the left, that's our input screen to the model, going back again to that basin. Each sub-basin within the model is color-coded, so those sub-basins are defined by the individual reservoirs, those 11 reservoirs throughout the system. The Cheops model itself produces the outflow from wateree. We're using that information to circle back into waterfall so that we can look downstream of wateree as well. And then on the right, it's really hard to see, are the water withdrawal and return nodes within the model. These are all input graphically, and then we have a database. And sorry, that's very hard to see, but we just wanted to give you an idea of what the schematic looks like and everything that's going into the model itself. So what does the model do? This gets back to that 101 training session from last 2 weeks ago, I guess, if folks were able to attend that. So it's really a water budget. And I think that a bank account was used as an analogy for in that meeting, where your hydrologic components, your inflows, and then your outflows are what are coming in and going out of your bank account. So in the model, we're taking into account the inflows. Again, those are coming from the waterfall model. And then outflows being evaporation, releases to downstream reservoirs. And then the water use is a net. So we're accounting for both withdrawals and returns within each reservoir subbasin. So we'll get into the waterfall a little bit more. We just wanted to highlight, the waterfall really truly is that inflow component, kind of the fuel to the system. So what is waterfall? I mentioned that it is a process model and a hydrologic model, and I'll get into the resolution of the model in a couple more slides, but it takes into account land use, land cover, soils type, which those components allow us to look at those alternatives so we can run future alternatives and change those inputs and see what that might mean to the runoff on the system. It's simulated on a daily time step. The inputs for precipitation are daily total precipitation and then mean temperature, and it's on a catchment scale. So really those HUC components. I already mentioned this a little bit, but it also, all of these inputs allow us to do that future climate change and land use modeling scenarios. So after the rainfall, hits the basin, it's using that daily total rainfall. It uses the land use, and I'll get into this a little bit more on the next slide too. It uses those land use and soil types in order to create runoff, and that runoff is routed through the basin. There's 15 model parameters that went into the model development. Those parameters were calibrated, and they were calibrated to actual USGS gauge data, so that we could make sure that this tool was actually representing the system and how it is reactionary to precipitation.
I have a question.
Yes,
Can you just point out, are the 1, 2, and 3, are those individual catchments?
they are.
And then all those catchments sort of make up that watershed? Is that-
Absolutely, yeah. So each individual catchment, it's additive, and as it's simulating catchment 2, part of that simulation for that catchment is the runoff total from catchment 1. So it's looking at what's occurring on catchment 2 as well as what's coming in from any upstream catchments. It is very spatially oriented, so it pulls in gridded data for temperature and precip. I remember, you remember Prism. It's Prism, but is it 4 meter? Anyway, it's very detailed gridded data for the precipitation and the temperature, and then it does a weighted average to calculate what those look like for each of those subcatchments to get the overall basin totals. And currently it's the historical data is based on 1981 through 2020 data. And then there's future projections as we look at alternative scenarios. So the previous slide was showing the precipitation and temperature. This slide is showing the land use cover and soil group information that went into the model. Those two components are combined to calculate what's called a curve number. The curve number is what the model uses to then use those soil and land use physical information to calculate the runoff and to route those flows through the basin. Part of this piece also allows or enables the calculation of timing. So if you have precip up in the upper basin, how long does it take for that to route through and reach the reservoirs? So that timing piece is incorporated as well through this process. So I'm going to transition back to Sarah. Sarah's going to talk more about the water use and the water use components that went into the modeling. Yes, but we want to pause. I kind of introduced very quickly what went into the model development.
No questions in the Q&A here, right?
All right, thanks, Angie. So as we just talked through, one of the key components coming into the model are those inflows. Another key piece are the water uses that are occurring throughout the basin in the model. And that we see as both our withdrawals coming out of the basin and returns going back in. So in order to calculate or accumulate those water use components for the model, we had to put together an updated water withdrawal forecast. So as part of the integrated water resources plan, we updated the long-term river basin model to include those values for withdrawals and discharges. We did that effort back in 2022. So you're saying, okay, what kind of withdrawals and returns are we talking about? We were able to put together withdrawals, an annual average withdrawal for each facility, annual average discharge or return back to the river for each facility in the basin. And then, so those are annual averages. There's also monthly water use patterns because we know, for example, with agricultural use, they don't use their annual average year long. It's going to fluctuate with the seasons. So we have a monthly use pattern for all of these users. And when you take your withdrawals minus your discharges, you get, or returns, you get your net withdrawal. The 4 boxes you see on the right are several of the key areas or types of users that we accumulated that data for. First and foremost are the public water suppliers throughout the basin, thinking about all of your drinking water utilities, all of the wastewater utilities being returned. We also have a number of direct industrial users throughout the basin. Think about your very large kind of paper plant or your textile mill that they don't purchase their water from another utility, but they have their own direct intake to one of the lakes. So we have those. We have a thermoelectric power for that generation. We have the energy plants. And then we also put together an estimation of agricultural and irrigation use. We have lakeside residential users who are watering their lawns. We have cropland and those filling troughs for cattle to feed. We have water use all throughout the basin. We put together estimates for each of those sub-basins of what's incorporated there. That also includes golf courses. So when we're developing this forecast, again, we have all the water estimated for withdrawals from the basin, returns into the basin, and that was done for each facility. So for example, rather than having just a single node for a single utility, it's a node for each drinking water plant or each wastewater plant they have so that you have them spread exactly where they are in each of the sub-basins. And in order to accumulate a lot of that data, particularly for the public water suppliers, we referenced those utilities master plans. We accumulated extra data through both North and South Carolina water withdrawal records and required reporting areas. And then for the Catawba Watery Water Management Group members, we had user validation interviews as well. We had at least one for many, more than one, discussion and meeting to go over the data we had from their past water use and validate the forecast for those water uses with each of those utilities. And that's what helped build our 50-year outlook of the water use forecast. So what does that forecast look like? So on the right-hand side of the screen, you can see time progressing from left to right. And then the y-axis is our net water withdrawals. So that's not just the water being taken out, but it's the water being withdrawn minus what's being put back. The orange solid line you can see starting from 2006 going forward to 2020 is generally increasing over time, but you see those kind of bumps and waves kind of going with some years are wet years, some years are dry years. And so that actual water use fluctuates a little bit year to year, but overall is increasing over time. So that's our actual net withdrawals that we accumulated. And then when we forecasted from that point forward, that's our light dotted blue line forward. What you see labeled as the 50th percentile mark, that's kind of our most likely case of what we think the future may hold based on the data we have. And then we also, as part of this integrated water resources plan, incorporated a probabilistic forecast in order to capture additional uncertainty. Rather than just sticking a pin on one particular number, hey, in 2075, we're going to be around 350 million gallons per day. Got that probabilistic forecast in order to understand the range of what the likely case might be. Looks a little bit like one of those hurricane maps where the hurricane eye is moving forward. Got this range of uncertainty of you don't know exactly where you're going to land within there, but there's a more likely cone that you're going to be. I do want to point out before I move forward, there's 3 individual orange dots. That represents 3 of the years of actual net withdrawals that we've tracked since this forecast has been developed. And you can see that those little orange dots, much like our solid line of what's happened in the past, has a little bit of variability year to year, a little bit up, a little bit down, but in general is increasing, and we're staying inside that cone of uncertainty. So it gives us an idea that we're along the right mark.
Good question.
Yeah.
How are the extreme droughts incorporated into this study? So I know you can't predict them all, but how wide does that cone or how narrow does it get based on extreme drought?
Yeah. So when we put together this forecast and the water usage, this is really honing in on how much water we think on average folks will use, withdraw, and put back into the river year over year. And so we think year over year, in general, people are going to use more water. So you're right, if we were to say a couple years out, have a big drought impact, those kinds of components of how operations and usage changes with a drought are going to show up in some of the other modeling components that we're going to talk through. And Jennifer?
There, we have an online question. How are you factoring in plan development and population forecasts in the water use, water withdrawal forecast?
Yes. So the key area in which future development and land use change impacting water uses were incorporated was part of, I'll go back here, part of that forecast development we did with each of the individual public water suppliers. So we spoke with them about their understanding of future growth and development for their individual communities. So that was all captured as of 2022 at that time. And also several discussions with broader economic development, county level conversations as well, in order to help validate those conversations.
Hey, Sarah,
Yes.
I guess some of those utility master plans would also consider things like, expansion of the existing water system to serve areas that are on wells presently too, right? Consider that.
Correct. If a utility anticipated in the future that that type of expansion would occur, we would include those numbers. We did include those numbers into this forecast. Thanks for those questions. Stop me at any time. So we have the forecast. One of the key questions that I know comes to folks' minds is, all right, do these water uses incorporate interbasin transfers? So you'll recall that I mentioned our forecast is focused on withdrawals coming out of the basin and returns going back into the basin. And when I say basin, I should say withdrawals coming out of the Catawba Basin and returns going into the Catawba Basin. Our eyes drawn immediately to the right-hand side. So I want to talk about that for a moment. We have the Catawba Watery River Basin highlighted in that peachy orange color. The Yadkin Basin is in that yellow to the right and the Broad on the left or to the west. These blue lines are representative of our major basin transfers, as we sometimes call them, that are currently occurring within the basin. See them spread throughout, and some of those being represented with a certificate or a previously established transfer. There are as well several intra-basin transfers, transfers that occur here just between the Catawba River and the South Fork of the Catawba River, and those aren't shown on the map here. But those transfers are captured as they were forecasted in that effort we were just talking about in our net withdrawal forecast. Because the difference between the total withdrawal, all the water being withdrawn from the basin, versus our net withdrawal, where all the water coming out of the basin plus what's being put back into the Catawba, that difference is primarily two things. One are the consumptive uses occurring throughout this area. Those consumptive uses being things like when you water your lawn and the water doesn't go straight back into the river. When an industrial user is doing a major process and a lot of evaporation is going into the sky, that's not directly coming back into the river. So those consumptive uses is one of the difference. Another difference is, or part of that subtraction that you would have, are wastewater discharges that are outside of the Catawba River Basin. So those aren't being brought back into the Catawba. So that's how we have inherently interbasin transfers accounted for within this forecast. And we're going to talk a little bit more about some of those wastewater discharges a little bit further on. So with that inflow component discussed and then water use with our withdrawals and returns, I'm now going to pass it back to Angie to talk about how the model handles moving water between each reservoir. Or I can also pause here.
So I'm going to get into the releases and really kind of the bug dust of the model logic, and what goes into the model and the operational rules that are embedded within the model, so that we're capturing the system as it's operated. So the model does account for the comprehensive or licensing agreement, and then it also has the physical limitations of the infrastructure as inputs to the model, so that we're not modeling something that physically can't be achieved. So for each reservoir and hydro station, there are definitions to define each of those, what I'll call a subbasin or reservoir subbasin. So there are the operational requirements of minimum reservoir elevations, spill elevations. The spill elevations are, when the model has reached its maximum targeted elevation, and it begins to operate spill gates. The target elevation, where are we trying to operate that reservoir at? The model will deviate from the target depending on other operational requirements. So if it's a low flow period or a high flow period, it will deviate around that target depending on that hydrology and what other constraints are implemented for that day. We also have fluctuation limits. These are seasonal ecological limits. So some of the reservoirs have operational bans during certain times of the year. We also recently updated storage curves for more updated information from Duke. And then we also look at the downstream flows. And we'll get into this in more detail, and I'll actually walk through what the model is doing kind of on a day-to-day basis as it's operating the system. But the downstream flows include the minimum flows, maximum flows. So what is the powerhouse capacity and what can the powerhouse discharge? And then if we're in a really high flow condition and we've exceeded that capacity from an inflow perspective, operating the spillway gates, and what are those capable of doing? And then also recreational releases. And in some of these reservoirs, there's some pretty detailed recreational schedules, and each of those schedules are modeled on a day-to-day basis. As part of this, we also have the low inflow protocol. So I'll get into more detail on the low inflow protocol and how the LIP is impacting each of these components, because the LIP does have factors that change our elevations and our flow components that are modeled on a biweekly basis. So jumping into the model logic, and kind of this is that walking through a day, I'll call it. So the model has the detailed inflows. Those are those incremental inflows that are coming from the waterfall model. So we have the inflows for Lake James, that is just the reservoir inflows. But as we move down through the system, it is a combination of your reservoir inflows as well as upstream discharges, and then outflows for evaporation and a net withdrawal return, sometimes outflow and sometimes inflow, depending on which reservoir it's at. So once we know what's coming into the individual reservoir that it's looking at, it then looks at all of those operational requirements we were just talking about, those elevation limits, the minimum flows, and also it looks at the LIP stage. And we'll get into the detail of the LIP in a couple slides. So we now have our inflows, we have our operational requirements. So what's our operational band for that reservoir? Then the model looks at calculating, okay, this is what I'm going to target for an outflow. So that is outflow equals inflow minus change in storage. Once it looks at what that calculated outflow is, it then looks at, okay, at the end of the day, if I operated this way, what would my elevation be? Am I still meeting my operational requirements, or are there any deviations? And if there are deviations, it will cycle back through. And it does this for the current plant that it's modeling, and then it also looks downstream. So if you're at one of the upstream reservoirs, is it providing enough water so that the downstream reservoirs can meet those minimum flow requirements as well as those operational constraints? And as we talked about, it will calculate spill if there's excess water. It calculates generation for each of the powerhouse. And then it cycles back through this entire process for each reservoir, and it loops through trying to meet all operational requirements for all reservoirs on kind of an iterative basis. Is there questions on that? Okay. So getting into the LIP specifically and how the LIP affects how the system and the model handles water uses and releases. We'll get into this in a bit more detail in each of the consecutive slides, but the LIP, jump to the next one. So the LIP is calculated twice a month in the model and in practice. The LIP takes into account lake storage, so what's available within the system for water volume, stream flows, so it looks at those, it's looking at USGS gauges, and then also where available, the National Drought Monitor, and it uses that group of information to calculate what the LIP stage is twice a month. The figure here is just showing a simulation of our LIP stages for an example. And you can see the historical 2006, 7, 8 drought there with the low LIP stages. So in terms of a water use, the LIP, we're modeling each stage has an incremental reduction in water use. So the LIP language, it has, so for stage 0, there is no reduction. For stage 1, there is a requested or voluntary reduction in water use. Stage 2, required and mandatory, and it's a range. Stage 3, required to increase the mandatory, and stage 4 is more of that emergency conditions. So from a modeling perspective, what we're modeling right now, we're modeling the upper end of stage 1, so a 5% reduction. And then stage 2, 3, and 4, we're modeling the midpoint of each of those. So for stage 2, for example, it's a 7.5% reduction in water use when the model hits that stage 2. I'm going to jump back for a second. So sticking with the LIP, other components that the LIP impacts are lake elevations. So the model is simulating the increased potential drawdown of the reservoirs depending on which LIP stage you're in. So it does take into account all of those pieces of the LIP. And circling back kind of on the KEOPS model as a whole, as well as the waterfall model, these tools give us the ability to look at the system and what potential changes might mean to the system from a modeling standpoint. We can look at for future potentials and what those might mean to reservoir elevations, water withdrawals, returns, as well as generation, and then also impacts to stream flows downstream. So I think I'm going to jump back to Sarah.
So when we have a modeling tool like the Catawba KEOPS model, we have all of these meaningful outputs coming out of the model, we ask ourselves, okay, what are we going to do with all of this information? And so for specifically the Catawba Water Management Group, and as they developed their integrated water resources plan, there are two key components that they were thinking about when we're thinking about the long-term future for the basin. One, and this is on the left-hand side, was the overall water supply volume, or the quantity of water that's available currently and under future conditions. So what is that amount of water stored either in a reservoir or in the main stem of the river? That answers our question, how much water is in the system? So we're using all of those components that Angie mentioned. We know about the reservoir storage, the elevations, and that's what helps us understand how much water is overall in the volume. But when we're thinking about the Catawba Water Management Group and their membership with all of these water users and the communities they serve, it's not just the amount of water that's in the system that matters. What really matters is how much of that water is accessible? How much of that water can we use? So that area on the right-hand side was really the focus of the integrated water resources plan. What is our water supply access or accessibility? And so that amount of water is accessible by our current water infrastructure or intakes. What can our current infrastructure access within our basin? And that really is what helps us inform our long-term planning to understand, okay, what is accessible now? What is accessible in the future? And when is that point when some of that water might not be accessible to us anymore? And we need to start making plans for other ways to either have a contingency plan to access water or be able to withdraw and use it for these communities. So water supply access, how much can we actually reach with our infrastructure was a key focus area. And when we're thinking about that accessibility with our intakes, we have a schematic here on the left hand of the side. If you can think of this as kind of a very simplified bucket of a single reservoir, that entire bucket is the total reservoir storage, up from however high you fill it to the bottom of the lake. But our intakes aren't at the bottom of the lake. Our intakes are usually in different points in that middle portion of the lake. So those black squares are kind of our representative intake elevations. And so when we have water within our reservoir fluctuating up and down, it's ensuring that that usable storage that's above the intake is available. So our remaining usable storage is the volume that is above that most shallow intake, because when that first intake, if we're kind of diving in from the top going down, the very first intake we're going to encounter, that shallow one, is going to be the one that's first uncovered when the lake level drops. So in order to frame that point at which we have to move to contingency planning, because I do also want to recall for utilities or many users, this intake may be one of the key components of their access, but also there's contingency planning in place regarding interconnections between other systems or the ability to put in emergency pumping or other activities. We're trying to identify when there's that decision point year where you need to move to contingency planning. So in order to identify that point, we're thinking about, for our long range planning purposes, the time when the system may be under the most stress. So for example, if the historical drought of record were to reoccur, and that's pointing back to that 07-08 drought, what if that major drought were to occur again? When is that most shallow intake owner, the one circled in yellow, our most shallow intake owner within a certain reservoir, going to be required to move to those alternative operational strategies that I mentioned? When are they going to need to go to their plan B in order to meet their projected water demands? Another component I want to point out here is, again, this evaluation with the decision point year is centered on when, if the drought of record were to happen again, when would the most shallow user within a certain reservoir subbasin need to go to their contingency planning? That's the frame by which the next series of results and figures I'm going to show you. So I'm going to show next a table representing our baseline condition, our baseline run for the model. And that baseline run for the model is representative of our current, our kind of current way of doing things. How all of the reservoirs are managed, all of the best information we know about the current water coming in, inflows, how big each of the reservoirs are, those current conditions. And under those current conditions, our baseline scenario, those decision point years of when that most shallow intake within each reservoir would need to go to an alternative operational strategy is kind of highlighted on boxes here. So if we take it from top to bottom, you can see here on the left-hand side, we have each of the reservoirs within the Catawba Waterway River Basin going from upstream to downstream. So starting with Lake James and flowing downstream to Lake Wateree. For Lake James, starting at the top, that baseline, in this baseline scenario, the decision point year for those alternative strategies is happening out beyond 21-25 in this simulation, these model runs. And that's the case for the subsequent 4 reservoirs. Then for Mountain Island Lake, that decision point year under these representative current conditions would occur with demands corresponding between 2075 and 2085. And then Lake Wylie between 25 and 2035. Again, the most shallow intake within that reservoir. Yes. Ken?
I think I remember reading that. I mean, so that's based on so many days below, 1 foot below the CRE, right?
Yes, yeah. And to dig in a little bit in those specifics, as you mentioned, Ken, when we're identifying that decision point year of what that threshold to help us define this decision point year, that threshold defined was 3 consecutive days, 1 foot below that most shallow intake.
And I guess for somebody who 10 years ago went through that previous plan, it was 1/10 of a foot for 3 consecutive days. I believe. So there was a decision made to change that slightly at this point.
There was a slight modification to that, and to briefly expand upon that, if you recall, so we had our 2006 water supply study, 2014-15 water supply master plan, and now this one. In the water supply study, it was for 1 foot for 1 day was the threshold. We then transitioned rather than a foot, bringing it down to 1/10 of a foot for 3 days. And we recognized here with this effort that it's probably a combination of those two that are most relevant. 1/10 of a foot is a very sensitive band within the realm of uncertainty that we understand for all of these pieces that are going through the model. But also that 3-day component is really helpful in that it's also representative that for many folks, or the majority condition, is that there's off-stream storage either up in your water tanks or within your water treatment plant or otherwise to help buffer out for a day or 2, 3 days before that intake restriction is becoming a component to really push you to your next operational need. And happy to talk about that more, Ken, well afterwards. Oh, and
Anthony Starr. So can you talk about why you chose 1 foot below the CRE versus something above, and the significance of when those systems can't withdraw water or those intakes don't become operational?
Mm-hmm. Yeah, and this is also, thank you for the question, Anthony, and also a good highlight opportunity to discuss that as part of this integrated water resources plan, we went through an update process and requested from each of the major intake owners within the basin to provide their updated intake elevation limit. And the request was not, where is your physical intake elevation, but rather what is the elevation at which you can no longer operate your intake. So our minimum intake elevations are already taking into account a slight buffer above the intake in order to maintain operation over the intake. So
So that CRE represents that
operational
intake,
Correct.
so not the physical.
Correct. As provided by each of the intake owners. And that compilation will be included. That whole discussion and request is a part of the IWRP.
Sarah, I'm going to make sure I understand, and the SAG understands too, the baseline scenario, when you look into the future years, uses the 50th percentile probabilistic demand projection.
Yes,
Okay.
yes.
Okay.
Thank you.
And I bring this up because I think Jeff Lineberger mentioned it as part of his a review of the integrated water plan yesterday at the summit, that the modeling does account for continued loss of storage due to sedimentation in the reservoirs. Is that a fair statement too?
There was modification for our basin storage based on the sedimentation that's occurred thus far. That's what.
And extending into the future at the same rate of sedimentation, or I guess that's what I'm asking.
So the simulations to date are representative of the sedimentation to date. So the projected sedimentation is not included
For this space.
for this
Or
baseline.
baseline, okay, understood.
Sarah, we have an online question, and actually it's also directed at Jeff.
Sure.
Pay attention. Brandon would like to know, Jeff, please correct him if he's wrong. It said at the summit yesterday, Jeff mentioned that during the 06-09 drought of record, some reservoirs lowered faster than modeled. It was determined that the water table dropped faster than the lakes, and the groundwater began flowing away in some areas. The question is, how accurate is the current model under extreme drought conditions? And was there enough data from recent droughts for testing/calibration?
My comment yesterday was about the 98 to 02 drought. It was the drought record at that time. That's later by the permanent 09. But in that 4-year drought, we saw groundwater reversal, and that's what caused the numbers not to work, and the lake levels were falling faster than expected. We didn't really see that in the huge drought of record. It's kind of like storms; they're all different. And that one, I guess it was the fact that we went 4 years with significantly reduced rainfall that kept driving the groundwater down there. So that's that piece of it. Was there a second piece to that question?
He wanted to know your comment, but I think the second part might be for Sarah, which is how accurate is the current model under extreme drought conditions, and was there enough data from recent droughts for testing?
So
You guys did a calibration.
yes, there's a calibration involved with this, and that a lot of that also driving from that updated inflow methodology that is incorporated as part of this plan as compared to the previous plan. So with that baseline, and Angie alluded to this as well, the benefit of having this tool is that we have an understanding of current conditions and potential future conditions. So we have our baseline scenario representative of our current conditions and operations, but we can also incorporate modified conditions to represent the potential future or potential alternatives to how we would react to the future. A couple of those areas that we incorporate into this model included scenarios impacting climate change, and that's primarily through modifying our expectation of how much inflow is coming to the basin. So for example, in the future, would that same amount of rainfall actually be less inflow or less rainfall? Higher temperatures resulting in increased evaporation rates, reducing the amount of inflows and availability within our reservoirs. We have variations based on our water demands. What if our precise 50th percentile most likely case is not the mark? What if that increases or decreases? Those projections. Operations and infrastructure modifications. We can make changes to physical infrastructure or how those dams are operated. And then as well, changing land uses we have a picture for future conditions, and that primarily ties into our understanding of future inflows as well. And there's a variety of different pieces, but I do want to hone in and zoom in on kind of these first three major bullets here of what type of alternative scenarios can be run using this model. And I'm going to show those results that were incorporated as part of the draft IWRP to illustrate them. I have a question. Yes.
Cindy Bean. On the climate change, does that take into account the sedimentation impact of heavy storms such as Hurricane Helene?
At the time when we first set this up, Hurricane Helene hadn't happened yet. But the important part is a lot of those sediment loading components are incorporated as part of our scenarios of changing land uses. And we do as part of, and let me go ahead and progress to the climate change scenario example here. There's variations in our storms that were projected in those climate change scenarios. So for example, understanding that we have maybe not overall very hot, those more frequent large intensity storms. So some of you all may have seen that there's a large number of future climate change projections for our globe, as well as for here, for us in the Southeast. With all of those various climate change models, there's a variation. They all project slightly different ranges for how much hotter our temperatures are going to get, and how much we're either going to be a little bit drier or a little bit wetter with our future precipitation. So there's a lot of different projections here. And those gray dots are representative of those. There's a bunch of these different climate projections ranging on kind of these two primary axes of temperature and precipitation. So knowing that there's this variety of climate change impacts, which are all, taking into account slightly different things, we developed within the Integrated Water Resources Plan 4 bounding scenarios. So if we want to capture and understand what if we go to this end of the spectrum versus this end of the spectrum. So we have our kind of more dark blue navy dots here. We're representing our 4 bounding scenarios. And those are, we know in general, it's not getting cooler. So is it getting warmer or hot? And then from side to side, going drier versus wetter, and capturing each of those 4 kind of combinations. When we take into account these 4 bounding climate change scenarios and use that to into our inflows for our modeling, you look at that same kind of decision point analysis, and you see that it makes a difference when considering water accessibility. So our blue boxes on here are decision point years from the baseline, which we just looked at. But if climate change impacts for each of those, we ran all 4 of those, there's a variation in what kind of changes they have. And that range is represented with those blue arrows pointing out to our gray extents. So you can see that for lakes Norman, Mountain Island Lake, and Great Falls Reservoir, those climate change impact range could bring us to a decision point year where that most shallow intake within the reservoir would need to shift to operational modifications, could occur closer to 2065. For Lake Wylie, that climate impact range shifts us either a decade forward or a decade back within these model simulations. And again, you might be like, that seems a bit odd, but you have to remember that some of the bounding boxes there for our climate variation is that there's slightly increased precipitation. And so that's what's pushing us to compute. We can see climate has an important impact that we're considering as part of this. And for any of those, again, where there's not a gray box on here, that means that the climate change scenario range was either the same or beyond the baseline. 21-25.
Yes, sir. Could you go back there? I would point out, Great Falls Reservoir is really small. And the only, water intake on it today is hydrostation intake. And, our policy is not to approve additional water intakes on Great Falls Reservoir because there are other bigger reservoirs nearby. So while that would show you the climate change, there's a problem at Great Falls, there will be no problem at Great Falls Reservoir. Other than, it could be a hydro impact, but, hydro turns into a big valve when we get into a drought anyway.
Thank you for that addition. So moving from those variations on climate impacts, for alternative scenarios example, we also looked at water demand variation. So we looked at this chart earlier with our projection for future water withdrawals, our net withdrawals, how much is being taken out of the basin minus what's being returned, primarily as discharges. And we used for the baseline as John reminded us to point out here with that dotted line of the 50th percentile. We reran it using the 95th percentile as well as the 25th percentile demand simulation. So capturing what if we really use the high end amount of water that would be expected? What if we use actually, 25th percentile moderately less than we expect or have forecasted? So looking back here at this baseline, our changes, I'll start with Lake Norman. With our high demand scenario, we use the 95th percentile, really the top of what may be forecasted for water demand. That pulls back that decision point year when the most shallow intake within the reservoir would move to operational modifications in 2105. For Mountain Island Lake, you can really see the spread in either direction of how much impact those water uses have on the decision point year, with that really high use demand scenario bringing forward that decision year about 3 decades, and with a low demand scenario pushing it out to that 21-25 range. Similarly, the range is fairly wide for Lake Wylie. If the high demand scenario were put in place, we're at 95th percentile. That operational contingency planning would occur 21-25 level of demand. But with a low demand, doing 25th percentile demand withdrawals, that extends how long into the future you would go before operational contingencies would occur by, 7 decades. All right, we're honing in. I've got 2 more kind of. Can we go back?
Can you go back a slide?
Yeah.
I'm Ray Weber with Lake Wylie Marine Commission. It looks like the high demand is right now for Lake Wylie.
If the drought of record were to reoccur right now, the level of demand corresponding to the 2025 forecast at the 95th percentile would
Make sure I
result.
was reading it right.
Yeah, you're right.
And I'd like the caveat of at the drought of record.
At the drought of record.
Understand. Thank you.
So we've looked at some modifications to our inflows based on that climate change input. We've looked at how we've modified our water withdrawals and returns based on kind of the probabilistic range of our forecast. Another component in these scenarios we're looking at here is what if we were to modify operations or the placement of our infrastructure within the system? And this really hones in on some of those alternative or mitigations that could occur. Look, we, as part of the IWRP, looked at a wide range and suite of these operational and infrastructure changes. The two main components that were modified were the critical reservoir elevation. So thinking about, okay, what if that most shallow intake were lowered? The other piece was with our low inflow protocol stage minimum elevation. And when we're getting into the nitty gritty of the low inflow protocol, recall with each of the subsequent increasing stages of the low inflow protocol that you go into from 0 to 1 to 2 to 3, there's changes for each of those reservoirs regarding how low each lake may go. And part of what that does is when Duke is allowed within this LIP to lower elevations further, more water can be discharged and sent downstream to support uses that are downstream. So that's why that matters. And so we looked at, again, this suite of many modifications across both these intake modifications and the LIP minimum elevations, and primarily focused on Lakes James, Norman, Mountain Island, and Wiley. You'll notice that in part that's because many of these have the most volume, as well as some of the most shallow intakes. So across that wide suite of many modifications, I'm going to show you an example of the results from these alternative scenarios where we put together a combination of a couple of these. So with some of these alternatives, modifications to critical intake, critical reservoir elevations, modifying intakes, and those LIP minimums, looking at Mountain Island Lake and Lake Wiley, that would push forward in time or support a larger volume of water withdrawals and returns, with Mountain Island Lake extending out to 2125 and beyond, and Lake Wiley to 2105 beyond this current decade, or excuse me, century. As always, our decision point year being representative of when that most shallow intake would move to contingency landing. Any questions here before I transition to another component that the IWRP took a look at within the context of changing conditions as compared to current? All right. With that, I'm going to pass it to Adam Sharp to talk about a different kind of alternative or component that we.
Okay. So, in the early to mid 2024 range, that was the timing that both Charlotte Water and Mooresville had published their notice of intents for a modification to their IBT certificate. So IBT became quite a significant part of the conversation for the Catawba Water Management. Okay, and the board expressed some interest, as part of this IWRP, to really understand sort of the characterization of interbasin transfers within the Catawba Basin. Okay, Sarah, an earlier slide for Sarah, she provided the map that identified, the first step was the who and where, who had an IBT and where was that water going, right? Was it going out to the Broad? Was it going out to the Yadkin? What was intra-basin within the Catawba? What was inter-basin that was actually leaving the main Catawba? So that initial characterization was the first step in the ask, by the management group and the board to really understand that. Another piece of that was really understanding what had already been authorized. There are two components. There are two characterizations of interbasin transfer. Some were grandfathered. In North Carolina, there was a grandfathering pre-93 when the statute was put into place anybody that had capacity to move water across the basin divide had a grandfathered capacity IBT. Okay? Beyond anybody that expanded beyond that number had to go through an interbasin transfer certification process to expand that value. Okay? So we went through and did a full characterization of that, and a lot of that's in the IWRP, and Sarah kind of showed that map as far as the main six that were inter-basin transfers above 1 million gallons per day currently. Okay. So the secondary question that the board was asking the IWRP team is, what is the influence of, interbasin transfer on the overall water balance for the Catawba Basin? Okay. What is the significance here? So, we structured one of the model scenarios to be able to, investigate or review what that was. And it was primarily focused on this wastewater return. So, as Sarah alluded to, the forecast for the model is based on two key components. Okay, what that total raw water withdrawal is versus what's actually being returned to the river. Okay, those two pieces. But the difference between that total withdrawal and net withdrawal is a lot of other things. The consumptive use that happens in the Catawba, consumptive use here that happens in the Rocky, the irrigation, cooling towers, and the like. And then there is the component that is a treated wastewater discharge outside of the river basin. Okay. So for this scenario, we specifically targeted one component of that overall equation. Okay. And taking those discharges for all those interbasin transfers that were discharging outside and return that volume of water back to the Catawba Basin. Okay? Again, the intention here was to be a scoping level understanding of what the influence of interbasin transfer is and returning those discharges to Catawba. Okay? The intent that there was no intention to replace the analyses that have to be done for regulatory process for anybody seeking a newer expanded IBT. It was really for the benefit of the group and the IWRP to have this level of understanding of what is the influence of IBT on the overall water balance for the Catawba. Okay? The other thing that we did not intend to do with this is say that this return was practical or feasible from an infrastructure standpoint, from a regulatory requirement standpoint. This analysis is not intended to jump to a conclusion that this could actually happen in the timelines required. Okay, it's really just looking at the water volumes and what the influence that is on the Catawba. Okay. Any questions on that before I talk about some of the results associated with this? Okay. So we looked at three key things, and it was all compared against that baseline scenario that Sarah had identified, where most of the reservoirs were well beyond that decision point year, well beyond 2100. Lake Wiley was 2035. Mountain Island was 2085. Those decision point years. We looked specifically at 2035, 2055, 2075 as part of this modeling evaluation. Okay, we looked at three things. Does this return actually influence that decision point year? Okay. And if it does influence it or doesn't influence it, how many days below that critical elevation? Okay, to identify a little bit finer resolution of the difference between those scenarios. And the other one we looked at was LIP stages. Okay, because sometimes we're not talking hundreds of millions of gallons. We are talking millions of gallons. Sometimes they may not affect the decision point year, but they could affect the durations of LIP stages and things like that. For the LIP stages, the change between bring all that wastewater back was 10 days. 10 days. It took 10 days out of stage 2 and put 10 days in stage 1. Okay, so there was a change there. It didn't change how many times it went to LIP. Didn't change anything in the most extreme 3 and 4, but it did do some movement of days between stage 1 and stage 2. Okay. So a lot of stuff on this table, okay? And, you know, I'm gonna pass through some stuff and then focus on Lake Wiley, okay? So this is your baseline scenario here that we've already looked at with Sarah. And these numbers are days below that critical reservoir elevation. And how many days during the drought of record does it stay below that critical reservoir elevation? Okay? This side represents the scenario where you bring all those discharges back for the Catawba. Okay? So for all reservoirs, excluding Lake Wiley, there is no change to the baseline condition, the baseline modeling scenario. Okay, no change in the decision point year, no change in the days, any of that. Okay, all the way out to some of the results we saw before. If we talk about Lake Wiley, I think number one is it pushes, you know, those returns push Lake Wiley, you know, from 2035 that we saw out to 2055. Okay. All right, so that timing for the decision point year when alternative mitigating strategies during the drought of record are required, it pushes it out, you know, between 10 and 20 years. Okay. The other thing you'll notice as well, obviously it reduces here the number of days because this is not exceeding the critical or below the critical reservoir elevation. You know, as you move out in time, okay, you see some reduction, especially 2075, reduction in the number of days below that critical reservoir elevation. Okay. Now, you may ask, all right, we're bringing water back under this one. Why is that higher than that one? Okay. You have to realize in these drought conditions, it's a daily time step model. It's very sensitive to the model 30 years in the future, very sensitive to a lot of different factors that are tripping that LIP. And during the drought of record, it can be coming in and out of that LIP. So that's the difference there. I think the salient point is under each scenario, okay, beyond 2055, you know, there's still over 100 days below the CRE, you know, requiring a mitigative alternative strategy to satisfy and access water supply. Okay.
That's a good question.
Yeah, absolutely.
Can you go back?
Sure.
How much, so that you're saying 15 discharge, is that what was modeled?
No, sorry. This is just an example to show it. So
What was the discharge that was returned?
So I can quote you the IBT numbers, which was 28 MGD in 2035 and 58 MGD in 2055. Okay, so that's the cumulative total for what that estimated, you know, transfer is for the entire basin.
So it's not stat based on today, it's based on anticipated growth?
Well, the 28 is sort of current state, and then the 58 would be the 2055 number. Yeah.
That was for the whole basin?
That's for the whole basin, yes.
So that's all IBT?
That's all IBTs. You know, and I mean, there are 6 currently that we focused on for this analysis that were inter-basin greater than 6 MGD.
How can that be 28 now? If not to call Charlotte out, I apologize. If they're reaching their limit near 30, that's thus the whole point of their request, right?
Yeah.
And you have others that have IBTs as well.
Good question. Good question. So that's on an average day basis. Every day, 28 MGD leaves the basin. Does that make sense? So the request now, the current certificates are based on max day. What's the 1 day max? So for example, Charlotte Water's current certificate, I believe 33 MGD, is a 1 day maximum transfer. Okay. And these values I just spoke of are average day, every day of the year. The current statute allows for max month threshold or a value certificate of max month. So it'd be a 30-day average in the maximum month. Did I
So
answer your
is that
question?
Because of seasonal factors?
Correct.
That drives that?
That's correct.
And then wouldn't you want to use the max then? Because when we're talking about our exceeding the CRE during, say, those summer months when the maxes are occurring.
Yeah.
That we want to take that into account versus the whole year's average.
So the way the model operates is it takes those averages and applies a monthly pattern to it. So you are including those peak monthly numbers. I was just quoting you the average day number. Yeah. So, to answer your question, that is included in that max month, peak. What's that?
It's somewhat smoothed over the whole, rather than spiking in the month, it's probably smoothed over the entire year. I mean, there's some seasonality is what you're saying.
Correct. And the seasonality is in the demand profile, that each month has a different profile. And over the summer, you have a higher demand profile than the winter. And it applies that seasonal profile to that 28 MGD. So I'm just going to put a number out there. So it's 40 MGD over the summer. I'm not saying that's the number. I'm just giving you an example that in the winter, it's 15. In the summer, it's 40, but the average for the year is 28.
Right. So I guess what we're thinking about in terms of water supplies, potential interruptions, right? And during those worst months when the demand is the highest, even using a whole month, if we have a 6 or 7 day period that's too high, and thus, that kind of gets us to a potential service interruption. Am I thinking about this the right way, or help me understand that?
Yeah, I would say, so the model functions on a daily time step. So all the inflows for the model are on a daily time step. But you are correct that the demands function, how they're calculated in the model, as a 30-day max month average in the model. Correct.
So it's a 30-day maximum, kind of a 30-day time look, but we don't have 30 days worth of storage in our systems, right? So if we, I'm admittedly not an engineer, and I'm way beyond my own.
No, the total time is good.
Reconcile that in my brain is using a 30-day kind of period when we might have 1 or 2 maybe days or so of storage if we get below CRE in our systems, and are we skipping over that possibility, I guess, is what I'm wondering.
I would say that the model is intended to be a planning tool to be ahead of those scenarios. That scenario you said, that's why we went through all the high demand scenario, the low demand scenario, the hot, dry. So we have all these data points to be able to plan for mitigating strategies, whether it's lowering intakes or mutual aid agreements to get ahead of those types of situations. By decades, not necessarily by years or days. Jeff, go ahead.
It's a good conversation. The one thing to consider too, though, is we've seen this in the South Carolina River Basin Plan. If you run a scenario that's just based on the absolute maximum of capacity approved for water intakes, you will get something that does not make sense. It will say that any river basin in this state, any river basin in North Carolina probably will say it is over allocated. And the reality is nobody runs at their maximum permitted capacity 24/7, 365. Nobody does that. So the way they have modeled returning this interbasin transfer water is very similar to the way they've modeled everybody's water intakes too. They have an ultimate capacity, but what they've modeled for long-term planning purposes on the water supply is what the average is expected to be, and then with the seasonality factors applied across the year. So this is exactly like they modeled Hickory's water intake.
Yeah, I guess where I'm going with this is, at least in the upper basin, I don't know about down here in this area, we've never experienced, at least in modern times, going below the CRE. We came close, right? And obviously you want to avoid that.
Sure.
So I'm just trying to think about a 30-day average doesn't help me. I'm thinking about how many actual days would it actually occur potentially with these models versus a model of a 30-day average. So that's where my mind is going on this scenario in terms of operationalizing this, the risks associated.
That, the numbers of days in the model below the CREs, that we have that information.
Yeah, that's kind of, that's the data here as far as the.
But if you're using a 30-day window is my point, then that, for the average, that baseline assumption, I guess, is what I'm trying to wrap my head around.
Sure. Yeah.
Thanks for indulging.
Absolutely. Yeah. Yes.
Yeah, I'm just a little confused because I'm thinking like you're pumping wastewater back. I mean, like you said, that's the scenario.
Mhm.
But you're talking about the volume would pump out would be equal to the volume of the IBT, or you're just gonna pump back a fraction of that?
Yeah. So this scenario was exclusively based on, taking, treated effluent, right? It's already been treated and bringing that volume of water back.
And those numbers there, it's 15 out of your total is 20, right? Going across.
Yeah. And maybe this chart was something I pulled from DEQ, from a presentation they use. These numbers are not necessarily, reflective of this exact one, but you are correct. The numbers aren't exactly equivalent to, things I quoted, but yes, we didn't do anything with consumptive use. So that 28 MGD, only a portion of that 28 MGD under this scenario is returned.
Okay, and that's just a straight typical percentage, like 85% ends up in a wastewater treatment plant, or?
No, so we went and talked with each one of the 6 utilities that have interbasin transfer, looked at their data to look at, what their projected wastewater discharges were from their facilities to then be able to estimate what those returns were now and into the future.
How feasible is it that they could return the entire discharge?
Again, this analysis was not intended to evaluate the feasibility of doing that. It was really intended to answer the questions of, what is the influence of interbasin transfer on the water balance for the Catawba? Anything with unlimited budget and unlimited, anything can be engineered. There's engineering marvels everywhere, right? There are challenges with accomplishing that. And again, that wasn't the intention of the scope of this review that the board had asked for. Yes.
Also, I mean, you routed it back somewhere above or below while,
Yeah.
Where'd you route it back?
So we also worked with the utilities to figure out where they would actually return that to, and what, like Mooresville, if they were to return something, would go to Lake Norman. Charlotte Water, if it was something would return, it'd be likely to be Mountain Island Lake because they have treatment locations and discharge locations already there. So yes, they would be above Wiley and immediately upstream of Wiley. But that would be the most logical place for those returns to happen.
And I know just from reading some of the meeting summaries from the water management group, I thought I saw that they were going to try you were going to model 3 scenarios. One was pump back of this, but another one was to take all of the water from the PD. Everything used in the PD come from the PD. Was that model run?
That model was not, no.
Okay. But this was the only one of those 3 options that you actually modeled.
Sure. This was the scenario that was modeled.
You got just a couple more slides, right?
One
more, okay.
Yeah, and I guess in closing and the build off, Jeff talked about this, some yesterday at the Waterfall Summit. This was done to obviously draw some insights to support the integrated water resources plan. I think the 2 key insights that came out of this that didn't have before we did this analysis is the IBT does influence the overall water balance for the Catawba. Okay, there is an influence there, but complete elimination, mitigation of IBT is not the singular solution to getting every reservoir and every water supply to a reliable supply in 2100. The goal of beyond 2100, the goal of the plan. So there are other things that are going to be required, as part of this planning effort, and all the partners in the group to move the plan forward to get all reservoirs to a 2100, beyond 2100. Yes, Anthony.
I agree. It's not going to solution, but it will accelerate how fast they have active IBT would on their supply. And second is, what are there, this 30-day window and these types of assumptions made, are these like industry standard assumptions, or are there other examples you use where they're modeling this in similar fashions, or is this something that is kind of novel to our situation?
I would say, so every basin model across the state of North Carolina applies the same principle. So the Yadkin, Cape Fear, Neuse, Broad, all of them use the same practice in the modeling. Yes. To your first question, in regards to this, minimization of IBT prolong some of those things, I say potentially, yeah.
Just to add on that, South Carolina's modeling process assumed similar assumptions, different scenarios, but along the realm of what you're seeing here. So South Carolina has done more or less the same thing that has been done in the Catawba. To look at modeling scenarios, variations in demand. In fact, I think some of the SAG participants may represent counties, be part of regional councils that are counties down below in the Santee Basin. The Santee River Basin model, the Santee River Basin plan came out late last year, and it included modeling that adopted the outflows coming from this modeling process, both the 50th percentile, the 95th percentile probabilistic flows Sarah provided to the modeling team, and those were used to do the modeling in the Santee River Basin in South Carolina. I want to mention that.
So final points on that, on the insights that were drawn from this analysis, some of the policy recommendations that made in the IWRP was looking at, sort of the statutory and regulatory, limitations on regional solutions. It talked a little bit about intrabasin. South Carolina has 6 or 7 basins that they regulate water withdrawals and interbasin transfer on. North Carolina has 38. So they took a much more granular level to split up the basins, and some of that granular level has become an impediment to regional solutions. Bringing water, from the Yadkin into the Rocky River, that is also an IBT. Okay, by the statutory definition of what IBT basins are. So the sub basins is just one example of some limitation in current statute that limits regional collaboration when it comes to the limitations of innovation transfer. So that was one of the policy recommendations for the group to progress to help remove some of those impediments to other alternative regional solutions to think big picture. So let me just do this slide real quick. So just to wrap this section up, as we've spun over the noon hour a little bit. So the draft IWRP is out for review. It's published on the website there, with the ultimate goal of having a final this summer in June. And then all of the membership, working towards resolution of support for that, for the IWRP, by September of 2026. Okay. And Jeff offered this up yesterday. The water management group, the board, the team is willing to support some of those presentations that go to all the boards and councils that have to approve that. So there is some support being offered to accomplish this. So with that, I guess I'll turn it back. Any final questions? Yeah, Ken, go ahead.
I have another question. And I'm going back to the 2014, 15 lot plan.
Okay.
Where there was similar analysis done. And my recollection is the failure point at Wiley has moved back in time, moved closer to where we are now. And I'm assuming, I mean, that doesn't make any sense that would happen, but due to CRE, because you've actually lowered the CRE. We've actually raised the summertime level of lakes in the upper basin. But what's driving that? Is that the change in the inflow? Because you're using waterfall now versus whatever you used before? Is that the primary change?
Yeah, I mean, Sarah, if you want to talk about that. Yeah. A very astute observation between the two plans, for sure.
Yeah. So what Ken was asking about is when we were looking at those baseline results, in particular with Lake Wiley, that baseline year with our decision point year being in 2035, that is a sooner year than was identified as part of the previous planning effort from the Water Supply Master Plan in 2014-15. Meanwhile, since 2014 and 15, there have been many accomplishments by the Catawba Water Management Group members, water usage, some identification and recognition of some lowered intakes, and other activities. So your question pointing towards that doesn't quite match what your expectation may have been. Going towards that, you identified correctly that one of the key components that is different is, and I think somebody else had a question about this, our understanding of actual inflows coming into the system during the drought of record has been updated and enhanced through using the waterfall model to identify inflows. And it really highlights for this basin and where we see stress here in Lake Wiley that we're very dependent on precipitation. We're dependent on inflows, and relatively speaking, our reservoirs don't have that much storage compared to the inflow coming. So you're correct, and a recognition of how low that stream flow was during the drought of record is part of what's driving that. And
Just add just a little, when you're doing modeling, you try to use the best data available. The best data available when we started this in relicensing was a reverse engineered calculation of inflow. And we used, we used stacks of hydro operator hourly operating logs, some of which were stored in trash cans in the basements of our hydro stations. But we went through all those. I think, Angie, we had 30 people.
we sure did. Digitizing all that, yeah.
So that was telling us how much water was being released from the hydro stations. And then we had to back calculate with a few long-term USGS gauges we had what we thought the inflow from the river basin was. And we also had to back calculate what we thought the public water withdrawals and industrial withdrawals were all the way back to 1929. We did this. It was a big time effort, but you had to do all that to figure out what the inflow series looked like. So you could even have anything to start with. And so that's what we used for the 06 water supply study. We made some improvements on that for the 2014 study, but it was still basically the same thing. It was based on that back calculation. We knew going into this update that we had to get better with what we could show people the stream flows were out in the watershed. It wasn't just about the lakes. We needed to know what was going on out in the watershed too. So that's why we needed to convert to a rainfall runoff model. And that rainfall runoff model also allowed us to make better evaluations of climate change impacts and better evaluations of land development impacts in the watershed. What impact that would have on both the quantity and quality of water flowing in the streams. That's why we did it. The things are just real sensitive there at Lake Wiley. They're very sensitive. There's a lot of water going out. There's a lot of wastewater coming back there. Wiley is a great big lake, but about half of it's really shallow, as Ray can tell you. So, the sensitivity of this model to changes in net water withdrawal at Lake Wiley is very significant. With a little bit of change, a little bit of reduction, relatively speaking, in water withdrawal, you can have a big change in where that decision point decade winds up, as we saw from at least one of these slides here. That's why we did it, Ken, why we needed to replace that back calculated inflow stream with one that had some more science.
All right, we're going to break for lunch now. If you're attending virtually, I think we figured out our technical issues. If you're attending virtually, we're going to break and rejoin. We're going to break and reconvene at about 12:40. But we ask that you put your email address in the Q&A, and then you leave the meeting and then rejoin the meeting. I'd say 12:35. That should fix our problem, and you'll be able to then be a full participant. You can unmute yourself and have more than just the Q&A. So please put your email address in the Q&A, leave the meeting, and then rejoin the meeting around 12:35. In the room, we'll start up again right around 12:40. For those in the room, lunch is at the back. I apologize. I said box lunches earlier. It's not. It's a salad tray and sandwiches. Thank you, Angie and Sarah and Adam. They'll be back after lunch to do a much shorter presentation on the Yadkin PD, and then we'll wrap it up after that.
Yeah.
I think the three of
Yeah,
them.
because I knew we were. I was still.
Yeah.
They raised
And I have a question. Am I wrong about, I don't like this considering Lord.
Capacity.
Looking at meeting. Getting table. And, buddy, will you help?
We're gonna start back up again, if you all wanna grab your seats.
I know we're well done.
All right, we're gonna begin with the second presentation from HDR, focusing on the Yadkin Basin model, a much shorter presentation. Both Sarah and Angie are gonna tag team this presentation. And before they start, let me just check, has Brandon Jones rejoined, Jennifer or Aaron?
Brandon has not yet contact with us, so we can hold that question.
Okay, Brandon had a question, but we'll address that hopefully when he rejoins. With that, I'm gonna turn it back over to Sarah. She'll walk through the Yadkin PD Basin model, and then we'll have time for questions. And after just a wrap up, we'll be done. Hopefully, probably before 2 o'clock. Sarah, it's all yours.
Thanks, John. Everyone, hope you had a good lunch. Okay. So for Yadkin Basin, not there it goes. As we discussed earlier, I'm going to start with a little bit of discussion about the Yadkin PD Water Management Group before we then go into their long-range planning process and ultimately their hydrologic modeling tool that they're using to support that planning process. So the Yadkin PD Water Management Group is an organization of public water supply users as well as reservoir operators within the Yadkin PD River Basin, at this time, all within North Carolina. The names of all of those members are on the right-hand side. I do want to draw your eye to the 5 of those that have kind of a yellow box around them. Those 5 members are also members of the Catawba Water Management Group that we've been talking about earlier this morning. This group has an origination that's a little bit closer to us in time. Beginning in 2016, they formed a memorandum of understanding in order to form the organization, and then ultimately created a 501c3 nonprofit for this group in 2023. This group and their organization has a couple of key purpose and goal statements here. Overall, this group of users and managers of the basin are looking to enhance the welfare of the Yadkin PD residents by jointly, so again, that collaborative element here, planning for the sustainable use of water for the basin. Their overarching goals include regional planning in a collaborative manner, having effective management of the river basin, optimizing those water supply resources that we have, facilitating a broader support and unified voice for their water supply needs within the basin, and having, again, a regional approach to drought response. Much like what you heard with the Catawba and here echoed through the purpose and goal statements, it's that collaborative regional nature for long-range planning in their full river basin. That's really top of mind. This group, in order to help achieve their goals, embarked upon the development of their own river basin-wide water resources plan. The vision for this plan was to ensure a sufficient supply of water in the basin long into the future by guiding regional coordination around their shared complex water management issues. So to dive into what this long-range water resources plan entails, let me show you a little bit of this development schedule. So this organization is currently working through this framework to develop the the water resources plan. They've taken a 7-phase approach in order to progress this year. Phase 1 being pre-planning, involve, set up the plan. A second step to identify what potential future or alternative conditions they wanted to consider in scenario development. Phase 3 and 4, where the hydrologic model is updated and used for evaluations. And then ultimately, those evaluations pushing towards recommendations concerning both water quantity and quality, so that the full collaborative evaluations can take place in phase 6 and roll out the document. We're going to focus in here primarily on those phase 3 and 4 components to talk about that hydrologic model that is used for the plan. As the water management group began this process to develop the water resources plan, they're like, okay, we're going to need a hydrologic model. And it was very serendipitous. The state of North Carolina at that time was simultaneously looking to develop the Yadkin-Pedee River Basin hydrologic model, which is the Oasis Yadkin-Pedee combined lumber river basin model. And so it's that model developed by NCDWR, Division of Water Resources, to be used for this plan. And so with that, we're going to talk a little bit next. I'm going to pass it to Angie to talk about this Yadkin-Pedee and lumber combined hydrologic model.
So as Sarah noted, this model is on the Oasis platform. So it's the Oasis Water Budget Balance Model. It was developed by North Carolina Division of Water Resources. The schematic you see over here on your left is the schematic of the model showing all of the nodes. And then each subbasin within the model is highlighted, is color coded. So you can see the different subbasins throughout the model. This is just zooming in on that schematic. So you can see a little bit of detail similar to what we talked about with the Catawba. It is accounting for the water balance and the inflows and outflows, withdrawals, returns throughout the basin. And this is just an example. So like it is that mass balance of water. Same schematic that we had for the Cheops model, but it's looking at the Oasis model on the Yadkin. So here we're just looking up at Kerscott and going down through Tuckertown. Again, they're taking into account inflows, water use, releases, the operational components of each of the reservoirs, physical constraints, all of the same inputs and outputs. The inflow development for this model, it has 80 nodes, 30 reservoir nodes. I think that's correct. I'm questioning that, but I think that's correct. And then the inflows themselves were back calculated from US gauge data and historical water uses. So utilizing the USGS gauges throughout this basin in order to create that inflow for the modeling. I think we're jumping right back to you, Sarah.
Yeah, so for this planning process, going into, again, that schematic, we have our water balance of the inflows coming in that Angie just spoke about. There's also the withdrawals and returns that were incorporated into the model. Water use and updated projections for future water use within the Yadkin-Pedee River Basin were developed by the Yadkin-Pedee Water Management Group, and they compiled all of that data in 2019. These uses are very similar to those I spoke about this morning. It's considering water uses from our withdrawals from public water suppliers, industrial users with direct intakes, accounting for some of that agricultural and irrigation use, with some of those estimates, as well as nope, I think those are them. Similar to the Catawba as well, we have, looks a little bit different in schematic, but the same principle of we're moving from upstream to downstream with these gray trapezoid subbasins you see. And from each of those subbasins, we have our withdrawals being pulled out of the river or the water source, and then the returns in red going back. And so with that, the net withdrawal being our withdrawals minus the returns are the green column following on the right-hand side. We did, as part of, for the ICMPD Water Management Group, do a slight revision to the water use and projections for several of the thermoelectric production sites within the basin, based on new information that the organization received in 2022. So with that, the majority of the historical data and then the projections going forward was compiled through 2019 with an update in 2022 to primarily thermoelectric components. So when we're thinking about these, those locations for the uses are kind of heat mapped for us here on the map on the right. Those blue circles are representative of the withdrawals. Each circle, as it gets larger, is demonstrating a larger volume of withdrawal. And then the red circles representing a return at that location in the basin, also corresponding in size. So with that, you can kind of see the concentration of uses within this basin. I think it's a little bit harder to see on here, but that's coming in a little bit on the southwest side of Winston-Salem, and then over in the Rocky River Basin. With that, these locations for these uses are linked to individual nodes, which Angie showed on the couple slides ago here. With each of those nodes, it's a node for municipal demands, industrial demands, those locations for wastewater that are linked to the water withdrawn. Water treatment plants have a process return related to each demand node. Some sites have just an individual wastewater return that's unrelated to a withdrawal. And then specific connecting arcs for interbasin transfers.
Sarah?
Yes.
There's a question online. It says, why are the withdrawals from High Rock Lake so high?
Great question. A couple components or factors about withdrawals being higher in that region have to do with several of the municipalities being in that area. Also, with these circles kind of overlapping, it's a little difficult to see. Many of them are not on High Rock Lake itself, but in the main stem of the river upstream of High Rock and below. There's some municipalities such as Winston-Salem, Salisbury, all coming in from upstream of High Rock Lake. I guess also for clarity of demonstration here, that red colored subbasin, maybe plum, that is all the land area draining into High Rock Lake, coming in right here. So these uses are all upstream of High Rock Lake, accumulating. Another component being agricultural uses in this space. So thinking about, again, that same schematic we had, we have our inflows coming in. We have our water uses and withdrawals going back and forth. And then as we're considering how water flows from subbasin to subbasin, reservoir to reservoir, we have releases and operations to consider. It's important to note that for the Yadkin Basin, unlike the Catawba, where in the Catawba, all the reservoirs are operated as a single system managed by Duke Energy. In the Yadkin Basin, there are 3 different entities that are managing reservoirs within the system. Most upstream is W. Kerr Scott with U.S. Army Corps of Engineers. There's then the Cube Yadkin, or a couple different variations here, but the Cube Yadkin grouping of hydroelectric facilities. And then downstream of that are the 2 Duke Energy owned and operated reservoirs. So when we're considering those main stem impoundments, as well as the smaller reservoirs that are within the watershed as well, that are contributing to the main stem, it's from the Corps' documentation, the Cube former Alcoa operations, Duke Energy, and then those individual public water suppliers for the ownership of those more localized reservoirs. It's that data that was incorporated into the Yadkin ED lumber oasis model. A final point on that is similar to the Catawba framework as well. Within this basin, there are drought plans, including the low inflow protocol that impacts the entire basin. So to talk about that, for this low inflow protocol, every month, on the first of every month, there's a consideration of what LIP drought stage they're in. The metrics that feed into the low inflow protocol are very similar, but not exactly the same as what's in the Catawba. Some similarities are consideration of that national US drought monitor, selection of stream flow gauges, USGS stream flow gauges. And then there is a component of the storage. But here, the storage, how much water is available in the system, it's zooming in and looking at the lake elevation at High Rock Lake. When the LIP stage is determined, and this is a prescriptive, just like in the Catawba, it's prescriptive as far as when you hit X triggers, you go to stage Y. And with that action, the LIP stage is determined. The low inflow protocol modifies a couple different components, including High Rock Lake target elevations, outflows from High Rock Lake, as well as Blewett Falls and Tillery. And also similar to the Catawba, when we have our low inflow protocol, there are tiers of water use restrictions and conservation measures that are directed within basin. The OASIS model takes that portion into account as well.
Ray Weber, Lake Wylie Marine Commission. So you have one model for the Catawba and one for in OASIS for the why does each one have a different one throughout North Carolina?
There is a river. They're not all complete at this point, so maybe you'll correct me. But there is intended to be a separate river basin model for each basin in North Carolina. Yes,
okay.
And these 2 models, respectively, the Catawba Keops and the Yadkin Oasis, are the approved model for use for North Carolina. So taking in those components, we have our inflows coming in, withdrawals and returns, modified and going back and forth. We have operations of the reservoirs, management, as well as directed water use reductions, all considered within this model. There are different outputs coming out of this model, out of this tool, that can be used to inform future decision-making for this long-range water supply plan that the Yadkin PD Water Management Group is embarking on. Honing in for the LIP, was there a hand?
Yeah, there is a question online, Sarah. It says, how are the releases between reservoirs treated?
How are they treated? I guess one of the key component is that for each of these the major reservoirs on the main stem of the river, there are various management plans or approved licenses for how they're operated. And then within those plans, there are set targets or goals or minimums that must be hit regarding releases for downstream flows. Variable based on, is it the core? Is it the other set or the hydroelectric facilities or otherwise? So outputs, and maybe I'll maybe go there then. So for each reservoir on the main stem here, we have, all of those not on the main stem as well, there are downstream flow calculations that are available with daily flows, as well as lake elevations that can be considered. Call it aesthetics. That can be thought of a lot as far as if you're on your lake side, would you prefer that your lake is at X height or Y height? And how close you stay within the preferred band of your elevation? Versus the other component is lake elevation as compared to water withdrawal infrastructure or the outflows for the various generating facilities as well. And then finally, a call out here to the drought stage, because as I mentioned, there's the low and flow protocol incorporated as part of this model and plan. The individual drought stages can be considered. And so when you take the baseline condition and iterate upon any alternative future conditions that may occur, you can take a look at these sets of metrics to evaluate and understand how things may change. And that's exactly what the Yadkin PD Water Management Group is doing right now in order to progress and move towards wrapping up their plan. They've completed the first 3 phases of the plan development, and in conjunction with the state's work with the hydrologic model and developed by Hazen. In progress and nearing completion at this time are those 4th and 5th stages related to their hydrologic model evaluations and looking at alternative future conditions and transitioning their focus towards alternatives and kind of mitigations that might be recommended for that collaborative step coming up in step 6 and close out with the plan. I say all of this to say that the Yadkin PD Water Management Group has been moving through this process in their planning, being a part of the team in order to, for example, as we talked about earlier, develop those water use projections and have them be reflective of their understanding, particularly of information they're able to get from their members. But the hydrologic model itself is completed and was approved by the state for use. And with that, that brings us to the conclusion of the Yadkin PD OASIS model, and really the 2 basin model components that we're going to talk about today. Do I see, Ken, you have a question?
Yeah, just, you said that in 2020, 2022, they did an update that affected the water use for thermal power.
Yes.
And I guess, I know in the Catawba Watery, in the IWRP, there's a projection for, the future projection was pretty significantly lower. Was it lower over there too, or? I guess maybe the real question is, to get to it, is there a change in electric demand that's been realized? I know there's some discussion in the IWRP about efficiency, which I understand, using less water to produce the same amount of megawatts. But is there, what What does it look like as far as change in demand? And then the other thing is probably a topic that's on people's minds is how much has been factored in for like data center power demand, that kind of thing.
Mhm.
And I don't know, Jeff might be able to answer better.
Yeah, and I guess I can start off, and I don't know if Jeff, you want to specify any of these components, but so again, that 2019 initial forecast that was done for this process, it took in it, and Duke Energy is a member of this organization, provided forecasts of their future water use based on their generation mix at that time. That update in 2022 was provided by them, and maybe Jeff wants to speak to this further, but I believe that was a reflection in part to an expectation of a modification of what type of generating facilities they were going to be using more in the future based on carbon type goals.
Every year we do a minor update to our integrated resources plans to the utilities commissions in both states. I think it's every third year we do a major update to it. So that 2022 update was as a result of changes in the integrated resources plan for how we're going to get the electricity our customers need. I can't remember exactly the difference over here, the 19 and the 22. It's not on the top of my head, but it is considering future technologies. You know, the integrated resources plans that we file with the utilities commissions are not river basin specific. They don't cite facilities. They just say what kinds of technology we're going to use and what the generation result of that would be. Then our team takes that information, extends it out 50 years into the future, and then applies those water using facilities to the river basins in the service area. So it's a lengthy process. We are moving to hopefully some more nuclear generation in our future, because we're going to have to do that if we are ever going to get to a carbon-free environment as far as generation goes. And renewables has expanded a lot. You know, North Carolina is second in the country in solar generation installed. So all those things get considered. And then our team just deals with the ones that use water. We are also building our first power generating facility that will use air cooling instead of water cooling down in Anderson County. It's a gas-fired generation plant. So be interesting to see how that one works. If that one is successful, it could really change our water footprint.
Can you pass that on to Google?
Pass it on to Google.
Yeah.
Yeah, they, the data centers have their own technologies and drivers.
Any other questions for Sarah and team about the Adkin PD?
We have one online as well
Good.
for Sarah. What are the major differences between the OASIS and the kiosk model?
There's a couple different differences. We highlighted those inputs, and majority of the parameters are very similar. There's a little bit of a different inner workings of, we recall Angie's walkthrough with each of the logic components. We're going step by step. What if each step, do you meet X criteria versus Y criteria? And then that's how you kind of transfer water throughout. And it's a different type of logic that is used in the background for OASIS. But when it comes to the withdrawals, returns, considerations of various inflows, evaporation, water being released from reservoir to reservoir, those pieces are all very consistent. I guess I don't know if Angie, you have any. All right.
You're doing these very long projections, 50, 70 years, and climate change being a great example of how you have to account for all kinds of wild variables. How do you vary your model based upon different scenarios? And the data centers, what made me think of this is that data centers weren't around 10 years ago. How does your model account for stuff like that that comes out of nowhere and changes all your projections?
Yeah, no, it's a component of all of these long range planning processes is that within each of these plans, we're taking in our best available information in order to develop models that reflect and calibrate to our understanding of now and do our best with these uncertain future conditions to capture the variability of what that could look like. Some components that make those future variabilities helps us take that into account are the series of sensitivity analyses that you're kind of seeing here. So for example, when we have the water demand projection curve going forward, and then our cone of uncertainty, what if we're using on the high end versus the low end? You know, that high end projection is helping us because we didn't know back in 2019 or in 2020 to incorporate data centers at that time in such a strong way. However, with that uncertainty cone, you know, we know we're probably going to shift a little bit on the higher end of that 50% maybe if data centers are as big as they are, but that's what helps us understand our future conditions.
Are these Monte Carlo-like variations where you just
They
run
are.
over and over and over with different variables?
They are. That for the Catawba.
So on the data centers, are they really a difference in, say, other types of users? Because like in our region, you know, they replaced some old textiles and there was a lot of capacity in those utility systems for textile manufacturers that had went away. And so I guess I'm thinking like, you know, how they kind of similar to other textiles, food and beverage manufacturers, that sort of thing. How much do you need to look at various types of uses versus data centers as a single anomaly?
Yeah, it's a good question, and I wouldn't say that I'm probably the foremost expert on data centers here. I can comment on a couple of differences on some of those different uses that you talked about here and highlighted. So they can be different or they cannot be different. And part of it is when we're thinking about, for example, a textile mill or paper manufacturer or others, there's a certain substance of withdrawals, but also more returns, wastewater returns that occur with something like maybe, for example, a bottling plant. There's withdrawals, and then that product is being shipped out somewhere, and it's not being returned at the same in a as equivalent manner as what's withdrawn. And similarly, the data centers, depending on their technologies, which can vary quite a bit, and I know others in the room know quite a bit about data centers, but depending on which technology they're employing at their data center, how much is being truly withdrawn and consumed versus what ends up being returned can vary. So that's, I think, part of the reason that data centers kind of stick out for us as a consideration for how that could change our profile for future water use.
In your future modeling, do you take into consideration or ever look at environmental permits that have been submitted for expansions, new facilities?
So for the long-range water supply plans, all of those water uses were accumulated for that long outlook by using the best available data that we received from those users. So if some users planned for future expansion, that expansion would be reflected in their projection for future use.
Thank you.
Mm-hmm.
But
yes, Steve.
on the Catawba TIOPS model, you spent a lot of time talking about critical reservoir elevations. And in the Yadkin PD Oasis model, it never even came up. Why?
Great question. So within here, So we were a little bit brief, but that is coming in here with that lake elevation for water withdrawal. We're looking at and evaluating the outputs of each of those lakes, what their elevation fluctuates at, and how that compares to the best knowledge available as far as critical intakes. There are listed critical intakes within the licenses, in the low inflow protocol for those main stem reservoirs available. And then as well, the ICMPD Water Management Group, actually this past 2 months, has been in discussion with their membership regarding those critical intake elevations.
Sarah, each of those reservoirs, Yankee PD will also have a critical reservoir elevation.
They will.
It's based on the shallowest operating installed storage water intake.
That is an added component that they are currently working on, yes.
One more online question here. Does the model include projections of water use for future nuclear or gas plants on the Yadkin PD?
Yes.
Yes.
Short answer.
Any other questions online or in the room about the Yadkin PD? If not, we do want to entertain one question that was submitted right when we broke the lunch. Okay, let's go back to Brandon Jones. If you're still online and you can unmute yourself, you had a question relating back to the Catawba, I believe. You want to pose your question for the group if you can unmute yourself?
Sure. Can you guys hear me?
Yes, we can.
Excellent. Yeah, I was just, again, thinking about the Upper Wiley, the challenges up there with Belmont's intake. And I know at some point, I think that Michelle had addressed the new Stowe Regional Water Recovery Facility. But I was just curious, like, what was the impact of that? It looks like they're permitted to 15 million gallons per day discharge right now. And that'll be upstream of Belmont's intake and then potentially up to 25 MGD at some point for expansion. And so is that helpful? Does that like show up, or is that such a small portion that it really doesn't change the models at all?
Yeah, Brandon, thank you for the question. I haven't spoken before, so I'll introduce myself. David Zer, Deputy Director with Charlotte Water. Brandon, good point with that. What he's referencing for the group, Charlotte Water has undertaken the construction of a new water resource recovery facility on the main stem of the Catawba and upper reaches of Lake Wiley called the Stowe Resource Recovery Facility. And effectively, we will be rerouting some of the flow in our system that currently gets treated at other wastewater treatment plants, and it will now be treated at this new facility when it comes online in about a year. And that will change where that water, cleaned water, is reintroduced into the Catawba River Basin. And I think the point, Brandon, there is that Lake Wiley is probably the reservoir that sees the most number of days at that critical reservoir elevation. We're putting water back into the upper part of that rather than it coming in much farther downstream in South Carolina. My gut feeling is that you're correct that would help, but I'm going to defer to Sarah and the HDR folks to be able to answer that from a more modeling perspective.
Perfect.
Thank you.
Thank you. And thank you, David, for the context regarding that facility. And I would say that when we incorporated the forecast of future uses, Charlotte Water knew that the Stowe plant was going to be coming online. So our future water use and return projections that are represented in all the results we showed you today included the fact that increased wastewater returns were going to be coming from the Stowe plant.
All right, unless there's any other questions on the Yadkin PD or even going back to the Catawba, we'll move on. Last call. Anything else online? Aaron? Okay. Well, thank you very much, Sarah and Angie. Appreciate it. Okay. Last couple agenda items we want to cover are just a preview of some upcoming stakeholder workshops that we envision. We're probably going to take a pause for spring and summer and have workshop 3 likely in the early fall. At least that's the current plan. In the interim, Brown and Caldwell is going to be working closely with Charlotte Water folks to develop their demand estimates and refine those. When we reconvene for workshop 3, focus there will be on reviewing and discussing that list of actionable alternatives, the ones that we want to take forward into the environmental impact statement, and reviewing and discussing the approach to do the detailed analysis. And that may include model simulations with the support of HDR. That'd be the third workshop, but that's probably not going to occur until early fall. Then there'll be a potentially 2 or 3 month time period where there's some work behind the scenes, including possibly modeling and further development of the EIS. We'll reconvene and review and discuss results of the preliminary analysis. There'll be another 2 or 3 month pause potentially for workshop 5, where we begin to review and comment on preliminary environmental impact statement chapters and the alternatives that have been assessed via the model. That's the current plan. Alex, with Brown and Caldwell, anything to add to that, or is that an accurate description of how you see this going forward? Okay. Any questions about that approach? I apologize. I know this is kind of a slow process. I appreciate everybody hanging in there. There's a lot of work to be done behind the scenes. And this is kind of how we envision it moving forward. We've provided a lot of background information, hopefully to both educate and inform. Is there anything else that you all envision as needing in terms of background information, so that when we reconvene for workshop 3, you're understanding what's happening, you understand the approach, you understand the modeling, you feel comfortable enough at this point, or is there anything else that you might suggest we offer? And you can think about that. And if you have thoughts after this meeting, feel free to either submit those to the Charlotte Water IBT email address or send them to me, and we'll consider them with the team, and we may offer up something else to help make sure everybody's prepared for these upcoming workshops. All right, before we adjourn, I just want to open it up to any further questions and discussion, if there are any.
Daniel Austin, Mecklenburg Solar Water Conservation District.
Sure, Daniel.
Are conservation measures included in any of your studies? And also, are just like the energy sector, improved technologies, maybe using less water, would there be more outreach on conservation and using less water and the quality of the water with farmland preservation and reducing sediment from runoff? Is any of that equated in here, or?
One of the Brown and Caldwell folks, Alex or Leslie, you want to try to answer that? Did you hear the question?
Conservation measures.
Yeah. Yep.
It'll get hard as we're working through.
I mean, they seem to be improving, although I'd like to see it a little faster, but I think there's a need for more outreach and education on the conservation side of it that would mitigate a lot of the use, the excess use. Thank you.
So, sounds like that may be more of a mitigation strategy, perhaps an actionable alternative. But that will be something that can be discussed. Yeah. Any other final closing thoughts or comments? Virtual folks, thank you for hanging on with us. Apologize for the technical issues. If you're online, now's your last chance to offer up any final remarks. Okay, with that, we will wrap it up. Again, just a reminder, charlottewateribt.org is the website. There will be a recording of this meeting posted to that website, probably in 3 or 4 days. Again, you can always provide written comments via email to ibtproject@charlottenc.gov. And any feedback that you have on today's meeting, again, send that forward. We'll consider that, compile it, and and be prepared to discuss it at the next meeting and make any adjustments as needed. Thank you, everybody, for your time today. I appreciate it, and we will be in touch about the next workshop, but that'll probably be early fall. Thank you all.
Sarah, you're right.